Welcome. You're at the cutting edge of cardiovascular sciences. Our guest tonight is Dr. Peter Hotez, and with me in this studio is Dr. Lee Lai, who will be introducing him. Dr. Lai?
Hello, everyone. It's our great pleasure to have you to the program, Dr. Hotez. So I believe everyone has known you very well since you are always on television news and the TV, newspaper. I also watch your YouTube videos and also the podcast that you have with Joe Rogan. Okay. So yeah, it's still my great pleasure to introduce Dr. Professor Peter Hotez. Is a dean of the National School of Tropical Medicine and professor of pediatrics and molecular virology and microbiology at Baylor College of Medicine, where he is also the co-director of the Texas Children's Center for Vaccine Development and Texas Children's Hospital Indoor Chair of Tropical Pediatrics. Dr. Hotez is an internationally recognized physician scientist in neglected tropical disease and vaccine development. At Texas Children's Hospital, he leads a team and produced development partnership for developing new vaccines for parasitic diseases such as Chagas disease and the viral illnesses such as SARS-2 coronavirus disease affecting hundreds of millions of children and adults worldwide, while championing access to vaccine globally and in the United States. So last year, Dr. Hotez's team developed a low-cost recombinant protein COVID vaccine, Corbevax, in Texas children for global health, resulting in emergency use authorization in India. So that is phenomenal, Dr. Hotez. Can you tell us a little bit how you made this as an academic team?
Sure. Well, first of all, thank you, Dr. Lai, for having me. Thank you, Dr. Cook. We've been making parasitic disease vaccines for most of my career. I'm an MD, PhD laboratory investigator, very interested in parasitic neglected tropical disease vaccines, and I'll talk about the Chagas vaccine this evening. But also, about 10 years ago, we adopted a coronavirus vaccine program because coronavirus vaccines back then, no one cared about them, just like parasitic disease vaccines. So we started making SARS, remember the original severe acute respiratory syndrome that arose out of southern China and affected Canada in 2002, then Middle Eastern respiratory syndrome out of the Arabian Peninsula. Both of those are coronaviruses. I said, look, we said it's a matter of time before we start seeing a third major coronavirus, so right on cue. COVID-19 hit. And so our group, which is called the Texas Children's Hospital Center for Vaccine Development, which is part of our National School of Tropical Medicine at Baylor College of Medicine, got permission to work in the labs. If you remember, a lot of things were shut down at that point. And our team, which is co-headed by myself and my science partner for the last 20 years, Dr. Mary Elena Batazzi, went to work to pivot our SARS and MERS coronavirus vaccine program into COVID-19, and we transferred the technology, the production cell bank, no patent, minimizing strings attached, to vaccine producers in 4 countries, in India, Indonesia, Bangladesh, and a group in Botswana. And the work with India and Indonesia really took off. We transferred the ownership. They produced, in India, Biological E, our partner there, produced Corbevax, which has now been administered to more than 75 million adolescent kids. Wow. And another 10-15 million adult boosters, so we'll hit the 100 million mark. Wow. And then our vaccine technology was also transferred to Indonesia, where they produced Indovac. That is an interesting spin on that one because our technology is a vegan technology. No animal cells or human cells. They're working it out with the local clergy in Indonesia to make it certified as a halal vaccine for Muslim majority countries. So they're now making about 20 million doses with plans for 120 million doses. So it's nice. It's kind of proof of concept that you don't have to be a big pharma company to do big things. And one of the things that I always say, part of the story is this would not have happened had we not been part of this amazing Texas Medical Center and Texas Children's Hospital and Baylor College of Medicine and our friends at Methodist. It's a place where you can still do big things. Even if you're in academic medicine, you're not constrained by that. We could still make stuff for the world, and so it's very meaningful.
It's a spectacular story, and really, it's a testament to your leadership in the field of infectious diseases. And it also, you are showing us the way to for academic centers to really have an impact on health directly. And I do agree with you that with some of the technological developments, it's becoming more and more possible for medical centers, for academics to actually get something useful to the clinic. Tell us a little bit more about that.
So you're right. I mean, the problem, the original plan was you do like most academic institutions, you make an interesting discovery, you bring it to the attention of your tech transfer office, and then they farm it out to the pharma companies, and they build it into an actual therapeutic or preventative or whatever. In our case, there was no there on the other end, because we were making vaccines for Chagas disease, schistosomiasis. And these are diseases for poverty-related diseases, and we finally realized, and we brought in some advisors, and they said, look, if you guys don't do it yourself, it's just not going to happen. So we, over the last 2 decades, we built that expertise in to know how to do scale-up process development, how to do it under a quality umbrella with quality control, quality assurance, how you do the documentation the right way, how you do an IND submission to the FDA and keep your product on stability protocol, because you're having things registered either with the US FDA or another national regulatory authority. So that was the hardest part to learn. It's also the funny thing, it's also the hardest part to get funding for, because if you have a donor, they want the cool innovation, right? They're prepared to fund that often, but then you start talking about your quality control and quality assurance units.
Eyes glaze over.
The eyes glaze over. They say, what's that about? And that was very special about Texas Children's and Baylor. They were willing to help support that, that you couldn't necessarily get only on grants, and that was a big game changer for us. Yeah.
I didn't know that background, and I really need to get your help, because with our Center for RNA Therapeutics, we're traveling down the same road that you've traveled, and you might as well get your guidance as we
so
do that.
We're a kind of a hybrid. And conversely, the other part is our scientists, our lead scientists, also have faculty appointments. And guess what? They need papers. So what we do is we will publish every step in the development pathway in the open access literature. And that has a dual purpose. One, it makes it open, because even if we don't get to the finish line on a particular vaccine, at least we've every step of the way, so others can, but also our scientists can get promoted and advance within the academic system by having papers as well.
Right, spectacular.
So the terrifying thing is, and the interesting thing at the same time, is there's no roadmap for this, right? Yeah. So we were kind of inventing it as we go in terms of what the overarching roadmap is for how you advance products for the poorest people in low and middle income countries. But it's also very energizing as well.
Now, your vaccine is a recombinant protein.
That's correct.
Vaccine.
That's correct.
Maybe before
through microbial fermentation in yeast.
Okay. So maybe you could just for a moment just tell us a little bit about the advantages and disadvantages of recombinant protein technology.
Well, the advantage is, one, it gives the same levels of virus neutralizing antibody as the mRNA vaccines, but it's an older technology. It's a vegan technology, so no animal cells or human cells. But it's the similar technology that's used to make the recombinant hepatitis B vaccine, which is also done through microbial fermentation in yeast. And the advantage there is parents and people are willing to accept it because they've already been vaccinated with a vaccine using that technology. But also, it's great in terms of there's no limit to the amount you can make. It's low cost. It's one of the, so for instance, Corbevax, I think in India is 145 rupees a dose, less than $2 a dose. So it's one of the least expensive. Simple refrigeration, very stable. So if you're thinking about a vaccine for global health, that technology checks a lot of the boxes. So whenever and the technology is used widely among a group that calls itself the Developing Country Vaccine Manufacturers Network. In other words, about 40 institutions in Asia, Latin America, and the African continent that are making vaccines. And a lot of them have that technology, so you can plug and play pretty quickly. So, often our default is to try to make a vaccine with that technology, then we can move relatively quickly. And I think Corbevax and Indivac provide a proof of concept that idea seems to work.
Oh, really spectacular. And I guess now we're going to hear from you about the Chagas disease, Chagas disease vaccine. And maybe we'll turn to Dr. Hotez's slides so that we can hear from him about his latest developments in Chagas disease and the vaccine for that.
Sure. Well, first of all, let me just say before I start that I really appreciate your taking on Chagas disease, because it's not a disease that many physicians and healthcare providers know about. Not even many cardiologists know about, because it's been primarily focused in the poorest regions of Latin America. Bolivia, for instance, has some of the highest prevalence rates. But now we're starting to see transmission in Texas, in South Texas, and not even that far south in Texas. So we're starting to see a fair bit of it. And it's showing up. You know, people are coming into cardiology clinics in Texas and I think elsewhere on the Gulf Coast with this condition, and it's often not getting diagnosed because there's not a lot of awareness for it. Right. So I think, you know, what our discussion today serves two purposes. One, to raise awareness about this illness among the community of cardiologists, but also a little bit about our work trying to make a vaccine for it and the rationale for it, because it's not a preventative vaccine, it's a therapeutic vaccine, almost like a immunotherapy, and I'll explain the need for that.
Beautiful.
So if I go to the first slide, this is our Center for Vaccine Development based at the Feigen Center, the research building of Texas Children's Hospital, and our portfolio of vaccines, which includes coronavirus vaccines, but also Chagas disease, co-headed by Mary Elena and myself. We sometimes call our vaccines anti-poverty vaccines because they're vaccines for diseases that are often chronic and debilitating in nature, like Chagas disease, so that these vaccines not only have a public health impact, but they also have the added advantage of maybe being an anti-poverty measure. So I also write books. This is the first book I wrote, called Forgotten People, Forgotten Diseases, to raise awareness about these conditions like Chagas disease or schistosomiasis, called the neglected tropical diseases. So Chagas disease is a parasitic infection. It's caused by a parasitic protozoan that's transmitted through the bite of what's called a kissing bug or a triatomine bug. And these almost look like cockroaches. They're about so big, and they live in the poor quality dwellings of people in Latin America, but also now in South Texas. And what happens is, as they're biting, they defecate out their old blood meal that contains the parasites. So people auto-inoculate themselves by rubbing it into open wounds or in the mucous membranes of the eyes and nose and mouth. And transmission is widespread across Latin America. This is from the Institute for Health Metrics and Evaluation, which assesses a lot of disease burden measurements. This is our latest enumeration from 2019. And there's about 6.5 million people who live with Chagas disease, and about 1 million of those with cardiovascular heart disease, what's called Chagasic cardiomyopathy, that I'll tell you about in a minute. And the areas in red and orange are sort of the ground zero for it. So the poorest regions of Brazil, northern Argentina, the Chaco area, southern Mexico, Bolivia, Venezuela now, and as I say, it goes all the way up Mesoamerica into South Texas. There's also, you notice that Spain is not the same color as the rest. So there's this phenomenon of globalization of Chagas, people with Chagas immigrating to other countries, including Spain, which has a large Latin American community influx. I think the game-changing thing about the southern U.S. is the party line was always that all of the Chagas disease cases were in the United States were through immigration. But our faculty, Sarah Gunter, Christy Murray, Melissa Nolan, who's now on her own on the faculty at University of South Carolina, found that, and Sarah Hamer at Texas A&M, find that up to 10% of the dogs are infected with Chagas disease in South Texas. So I always make the point, the dogs are not slipping in across the border, right? So we have transmission here, and that's a good marker for that. So it's not only immigration across the southern border, but there's actually transmission here, which is a message that's been very hard to get across. Also a big economic impact because it's so chronic and debilitating of the heart disease. So we work with a group at City University of New York in the School of Public Health that does a lot of modeling, disease modeling, and health economic estimates. And it's headed by, his name is Bruce Lee. And Bruce has done a number of studies, and there are some numbers there looking at the huge economic impact of this because of the hospitalization costs, the drug costs, and having people out of the workforce because of Chagas disease. And this is a kind of closer, deeper dive into the transmission through vector control in what's sometimes called the southern cone of South America. If you think of South America, the shape of a big ice cream cone, there's the ice cream sitting in the cone. The cone part has had a lot of success with eliminating the disease just through vector control, just through indoor residual spraying, because the kissing bugs are living inside the poor quality dwellings. The problem elsewhere in Latin America is there are different species, and so some of them live outside as well as inside. So even if you eradicate the bug through indoor residual spraying, they're still reinvading. So vector control alone has not been sufficient to control.
So this
disease.
parasite is actually present in several different related vectors, or this different species.
Different species of the triadenine vector, and each, and that's a very good point. So each different species lives in a different part of Latin America, and there are actually some genetic differences between the South American strains and some of the Central American and Mexican strains, and the ones that are deeper in South America tend to cause as much digestive illness as they do cardiovascular illness, whereas those strains up here and in Mesoamerica, meaning southern Mexico and Central America, more predominantly cardiovascular involvement as well. This is where Chagas disease occurs. Interestingly, even though this is the disease of poverty, it peaks in the 3 to 4 richest countries in Latin America: Argentina, Brazil, and Mexico. So 1.5 million people living with Chagas disease in Argentina, 1.156 in Brazil, 0.876 million in Mexico. These are enumerations from the World Health Organization. And so this is another important concept in neglected tropical diseases. The poor living among the wealthy are disproportionately infected. You know, when we think about tropical infections, we always think about them as affecting the poorest, most fragile nation states on the African continent or in Southeast Asia. But it's actually the poor living among the wealthy on a total numbers basis that actually accounts for most of the world's poverty-related diseases. So that the failure is often not a resource problem, it's an awareness problem and a policy failure. And I've written actually a book, because I like to write books. Another book that I wrote is called Blue Marble Health, and I gave it a different name from global health, because when we think about traditional norms of global health, it's always about poor versus rich countries or developed versus developing countries. But it's the poor living among the wealthy that actually account for most of these diseases. You're from China, so for instance, if you go into Shanghai, right, it's a very wealthy city, but you go into southwestern China, into Guizhou or Yunnan province, there you have a lot of poverty, and that's where you find neglected tropical disease. It's the same in Latin America as well. So I gave it a new name. It's a concept that really hasn't taken off. I call it Blue Marble Health, just to kind of shake things up a bit and give it a different name, the poor living among the wealthy. And that's well exemplified by this concept of Chagas disease, including the poor living in the United States. Another hotspot area has been Venezuela, because of the socioeconomic collapse linked to the Maduro regime, which has interrupted vector control efforts. So and it's not only Chagas disease, leishmaniasis, also halting of vaccine-preventable diseases. And so this is another hotspot area that I've been writing about with my colleagues, Dr. Paniz at Mount Sinai and Dr. Grillet, and really looking at Venezuela as an important area. And unfortunately, it's destabilizing the whole continent because it's bringing back measles, because of interruption of vaccination programs, and then people are exiting the country, going across the border into Brazil or into Colombia, and then therefore it's destabilizing the whole continent in terms of malaria, Chagas disease, and elsewhere. And then this phenomenon of globalization. So there's Chagas disease in Japan. In that case, it is through immigration, or in Southern Europe, particularly Spain and parts of Italy. So some of the real expertise in Chagas disease is actually conducted by an organization known as IS Global. It's our Global Health Institute in Barcelona. And so they're doing a lot of important research in Chagas disease, as well as in the United States. But again, that very important piece to emphasize that we have transmission here. This is a map, a risk map of Chagas disease generated by my colleague, Professor Sarkar at the University of Texas in Austin. And you can see definitely in South Texas, but it goes pretty far up. So there's transmission here. And one of the surprising things is our faculty was looking at working with the Gulf Coast Blood Bank, because if you donate blood, they will actually screen for Chagas disease. And what we noticed was individuals were told, well, we can't accept your blood because we've diagnosed you as having Trypanosoma cruzi infection, the etiologic protozoonation of Chagas disease. You better talk to your primary care physician. Primary care physician would say, oh, that's probably a false positive. We don't have that disease here, because there's this lack of awareness. So this is why things like this are so important. And it turned out that when Dr. Murray and Dr. Nolan, Dr. Gunter started looking at this, some of them had heart disease and got referred to cardiologists here in the Texas Medical Center, including at Houston Methodist, because they had Chagasic heart disease. So what happens is this trypanosome, when it does get inoculated, and I'll talk to you about the routes of transmission in a minute, just a little bit of the pathogenesis. It's a single cellular, unicellular protozoan parasite. Some relationship with the causative agent of African sleeping sickness. The differences with the causative agent of African sleeping sickness, which is known as Trypanosoma brucei gambiense or rhodesiense, that's exclusively extracellular. In the case of Trypanosoma cruzi, it has the ability to get inside cells. It actually penetrates through cells, breaks out of the phagolysosome, and lives in the cytoplasm as a rounded up ball, which is known as an amastogote. And so that's the stage of the parasite that's in our predominantly in our body tissue. So the parasite will circulate in the blood for a while, then it'll go deep into the tissues, living that intracellular existence.
In that state, is it metabolically active?
It's metabolically active, although it's going through also a period of dormancy, and I'm going to show you some slides in a minute to kind of flesh out a little bit more. And let me just quickly tell you the modes of transmission, because the bite of the blood-sucking triatomine insect and different genera like Triatoma, Rodnius, Panstrongylus, it's as the bug defecates the old blood meal out that you auto-inoculate. That's the major route. But now what also happens, for instance, in Venezuela is sometimes the kissing bugs that contain the trypanosomes get crushed in the preparation of juices and things like that. So you can become orally infected by that route.
Wow.
And then there's a third very important, which has been studied intensively by my colleague Pierre Buchans at Tulane, maternal fetal transmission. So if you're pregnant with Chagas disease, about 5% of those cases will get transmitted vertically to the neonate and to cause acute Chagas disease, neonatal Chagas disease, which is also under-recognized. So those are the three major routes. So it's very much a maternal-child problem. So when you first become infected, what happens is the trypanosome will cause an acute phase, which is more often than not without any symptoms at all. So it's silent, it's asymptomatic. Other times it'll be associated with fever or inflammation at the site of where you inoculate the bug feces in. So if you're a kid and you're rubbing your eye, it'll actually get into you'll see it with an edematous eyelid, which was first described by Dr. Romagna, so it's called Romagna sign, of course. And it's associated with lymphadenopathy and sometimes hepatomegaly. And that acute phase, again, which is often asymptomatic, will last 1 to 2 months, 4 to 8 weeks. Sometimes you'll see an acute myocarditis associated with it. Oral transmission tends to be more associated with more severe infection. That acute phase, if it gets diagnosed, responds very well to antiparasitic chemotherapy. And the two major drugs are called benznidazole and nifurtimox. It requires a long treatment course. The problem is patients either don't have access to treatment centers or the medicines because they live in poor, remote rural areas of Latin America, or more often than not, it doesn't get diagnosed. And so what happens is, so once you become infected in the acute stage, you seroconvert, you become seropositive. Most patients then do okay. They will not progress the symptoms. So what happens is, in the early stages, you're not really showing any symptoms at all, and you're kind of in limbo. Because you don't really know where you stand. So you're seropositive, you're infected, but you don't know if you're going to go on to develop symptoms or not. And in the Chagas literature, they use a very specific term to describe that. They say you're of indeterminate status. And about 60 to 75%, 2/3 to 3/4 of patients will remain indeterminate their entire lives and not progress the disease. The problem is 25 to 40% will progress to the determinant stage, and particularly in places like Mexico and Central America and now southern Texas, that determinant stage where you're symptomatic manifests as Chagas cardiomyopathy, where the parasite, those amastigotes, are actually in the heart tissue. And and so this is kind of says it here, and pretty much a slide saying what I just said. Indeterminate, seropositive without overt clinical symptoms, maybe subtle cardiac and digestive involvement, and then the determinant stage will often be a decade or 2 decades after you're initially infected, and you'll either manifest as a Chagas cardiomyopathy, or what's sometimes called chronic Chagas cardiomyopathy, or CCC, or the digestive form further in the southern cone of Latin America as megaviscera, where you actually have denervation of the autonomic nervous system of the esophagus and colon, and you get massive dilation, what's called megacolon or megaesophagus. Now, as a cardiologist, you're probably looking at me and saying, well, what the heck does autonomic nervous system of the gut have to do with the heart? And the answer is, I don't know. And I think this is sort of a medical mystery. Why those two things, which intuitively don't have anything obvious connected with one another. But it does seem that certain demes or genetic variants of the parasite tend to do more one than the other, and it tends to localize geographically.
When you go from this indeterminate state, you say the 20 to
25,
40%,
30%,
go to a determinate state, and they start developing a Chagas cardiomyopathy. Is that due to, as you get older, your immune system is starting to fade, or is it due to multiplication of these parasites in the heart? What's going on there?
So there are different theories. One is saying it's, as you point out, others saying it's due to a hyperactive immune system, and that it seems to have a Th1 predominance. More gamma interferon and Th1 type cytokines has been associated with heart disease. So we've actually had a group now look at this, headed by Catherine Jones on our faculty, and she just recently graduated, or a couple of years ago, a PhD student, Catherine Hoffman, who looked at this and made some interesting findings, and that is when the parasite goes into the heart, and is that asymptomatic form, it tends to be inducing two pathways, one which is leading to inflammation, and the other leading to fibrosis. So it's laying down collagen. So if you were to do a Mallory trichome stain of the heart, you'd see lots of blue because of all the collagen deposition. So it's that 1-2 hit of inflammation together with fibrosis that seems to be driving Chagas cardiomyopathy. And I don't know if I have a slide, so I don't have so let me just tell you briefly about it. So the clinical manifestations vary. One is in the most extreme form, you can get a big dilated cardiomyopathy with a lot of fibrotic deposition and heart failure. That's one form. Another are the formations of cardiac aneurysms that form. So again, ballooning out of one part, not a completely dilated cardiomyopathy. I'm not a cardiologist, so I'm not being very eloquent on
No, that's
how I
fine.
articulate this. Then the other is that the parasites in the fibrotic deposition gets into the conduction system of the heart. So you get arrhythmias, and you can even get sudden cardiac death. That's been well described. The other things that can happen is with that dilation and cardiac arrhythmias, you get clots forming, and then you can get stroke as well. So it's a bad actor. So what happens is about once you have Chagas cardiomyopathy, there's some studies to suggest that over a 5-year period, about 18% will die from Chagas cardiomyopathy. So it's a pretty serious cause of illness and death. And the problem is the treatment. Again, in the acute stages, patients seem to do better, and both. We tend to use benznidazole more these days than nifurtimox. Neither have great tolerability because they can cause peripheral neuropathies, blood dyscrasias, and the problem is they tend to be pretty long treatment courses for up to 1 to 2 months, and sometimes patients have to halt therapy because it's too difficult to tolerate. It works pretty well for acute and congenital disease, pediatric disease, if you make the diagnosis. But the problem is, once this process has been going on and you develop determinant chronic Chagas cardiomyopathy, even though the medicines can often sterilize the number of parasites in the heart, and so you don't you often still will pick them up by PCR, but you still may not serorevert. So you still have that chronic infection. So it's not doing very much in those late chronic stages because the parasite is still in the heart. So the question is there some other type of adjunct therapy that you can do to kind of get you over the finish line, so you're not in that 18% number of losing your life? And so we've been working with a number of other groups, including the group at University of Barcelona, called IS Global, their Global Health Institute, the Drugs for Neglected Disease Initiative, DNDI, which is even bigger than our Texas Children's Center for Vaccine Development. They're focused on new innovative drugs for neglected diseases based in Geneva and Paris. They're a spin-off of Doctors Without Borders, MSF. Now they're on their own. In fact, their founding director, my friend Bernard Pacul, just retired from there. They have a new director now. Mundo Sano, which is a group based in Argentina, is involved, and several others. So we formed this Chagas Coalition, which is headquartered in Barcelona, to really look at the development of new therapeutics, but raise also the awareness. So we even have an International Chagas Day now. And there have been some promising lead candidates that are similar to benznidazole, of the azole class, like fexnidazole and some of the others, to see if we can get improvement on benznidazole. But what we're doing is seeing if we can develop a therapeutic vaccine. And the idea behind it came out of our colleague Eric Dumontil's lab, who was based at the Autonomous University of Yucatan, and now he's moved over to Tulane University. They were doing DNA vaccines, both in rodent models as well as a dog model, because it's a big problem with dog, and getting a lot of success with a DNA vaccine for two candidate antigens. One, a calcium binding protein called TC24, and the other one, TS1, which is TSA1, which is a transsialidase. And the only problem with DNA vaccines for people is, as you know, they haven't really translated well into the clinic. So what DNA vaccines have worked very well in rodent models, but we don't have a single licensed DNA vaccine for humans, but we have lots of protein, or several protein-based vaccines. So the thinking was, and I'll talk about mRNA in a minute because we are looking at that approach, but the thinking is, can we reproduce this with a recombinant protein vaccine, either TSA1 or TC24? And that's what we've done. We've have this candidate, TC24. We've modified it. It has that designation TC24C4 because just like our COVID vaccines, if you have intermolecular disulfide bond formation, it gets harder to control the process. So in this case, the cysteines are modified so you prevent intermolecular aggregation. And then we combine it with a TLR4 agonist, a toll-like receptor 4 agonist, that's available for an organization that used to be called IDRI, the Infectious Disease Research Institute in Seattle, and now they have a new name called AAHI, AAHI, and in a stable emulsion. And that's the vaccine that we've been doing quite a bit of preclinical work on, that our group of scientists, including Catherine Jones, to show that you can, in combination with benznidazole, have an accelerated effect of reducing the progression of disease, both in terms of fibrosis as well as the progression of inflammation, ideally by inducing more of a balanced response. So if you go too far hot and heavy into the Th1 response, it actually exacerbates inflammation. So you want to be able to stimulate both IL-10 as well as the traditional Th1. So balanced Th1, Th2, and also Th17 response. And that seems to be working pretty well there. We're looking at the mechanism by how this is working. Leroy Versteg is a doctoral student and working in our group, and he and with Jeroen Pollitt have noticed that the expression of this TC24 seems to really rev up as the parasite is leaving the cell. So that seems to be the place where it's being presented. And now with Eric Tuman Thiel's group, we're doing non-human primate studies both with TC24 and TSA1. It may turn out to be a bivalent vaccine, but for now we're looking at getting TC24 into the clinic. And in collaboration with Houston Methodist, we're now looking in the Center for RNA Therapeutics, and what you're doing, we're seeing maybe an RNA vaccine might also be an option, and we're looking at it with other groups as well. And that includes looking as a straight-on mRNA vaccine, but also as a prime boost with protein, which seems to be a little bit even better. And because it's a therapeutic vaccine, that you're not vaccinating a whole population, that might be feasible. So Jeroen Pollitt and colleagues have done a lot of exciting work looking at some of the polyfunctional T cells in response to this combined vaccine. But for now, the protein-based vaccine will enter into the clinic in a phase 1 clinical trial in Mexico with a consortium of Mexican institutions, including Cinvastav, led by Jaime Ortega, who's done a lot of the protein, also a lot of the protein expression work. Also, a ProBioBed, which is a local vaccine producer, making recombinant protein, so they'll do the GMP production. Working with the Autonomous University of Yucatan, Autonomous University of Mexico, UNAM, the big university. So it's very exciting. We hope this will go into phase 1. This is my last slide. That will do an initial study just to look at safety in healthy, normal volunteers, and then look at it in individuals who are infected with Trypanosoma cruzi, ultimately with the goal to reduce the progression of illness. So thank you again for the opportunity to talk about this. It's, it's in this time of COVID-19 and other respiratory viruses, it's not easy to get Chagas disease on the radar screen. And it's yet so important. I appreciate the opportunity to be able to talk about it.
Well, we appreciate having you here to talk about it. And great news about the vaccine going into phase 1 studies.
Thank you. We've had support from the Kleberg Foundation locally, what used to be called the Southwest Electronic Energy Medical Research Institute. They've been great supporters. other organizations, and the Slim Foundation has been the Cardiovascular Slim Foundation now
All right.
has really been helping us quite a bit with development. Also the NIH, of course, NIAID.
Great news. The vaccine is against this TC24. It's a flagellar protein. These parasites are at the stage we're talking about that's causing Chagas cardiomyopathy. They're intracellular. So does this stimulate? Does your vaccine stimulate a cytotoxic T cell response to clear those cells that have the parasite?
It can, but again, if we go too strong on pure CD8 responses, you have to be careful. You could exacerbate inflammation. So we try to seek that balanced response. But we do think CD8 positive responses are interesting. Interestingly, when we started working with this TLR4 agonist, several people have said, forget it, it won't work because TLR4 stimulation won't stimulate CD8 positive cells. But we were stimulating CD8 positive cells, so either that's not true or other things are happening with these adjuvants. This is always a chronic problem that we have, being making vaccines for parasitic infections is adjuvant access, because the big pharma companies often fiercely hold on to the intellectual property for their adjuvants. So we're left with a handful of open access or adjuvants, or with nonprofits like working with AHI.
I want to give the folks at home the opportunity to join us. You can join by web. You go to polev.com, enter DeBakey, and respond to that activity. Alternatively, join us by text. Text DeBakey, that's DEBAKEY, and I can't read that, 37607, is that right? 37607, and text in your message.
So while we're waiting for the question, can I ask the first question? So I'm actually curious, how did you find this TC24 protein? Why you target this protein?
Well, we do have a program of genomics and reverse vaccinology, and so Kamal Rao in India is helping us with that for antigen discovery. But in the case of TC24, it had been around a while, and it was really Eric Dumontil's group that provided proof of concept that it could be used as a vaccine, either as a preventative vaccine or therapeutic vaccine. So, for our parasitic disease vaccine programs for hookworm and schistosomiasis, we do the antigen discovery. But in the case of Chagas disease, it came later when we first moved to Texas, and so there had already been some published literature on candidate antigens, including from Eric's group, so we picked it up from there.
Mm-hmm. I've read that the Chagas disease is, as you mentioned, it's spreading north, and what I've read is that this is in part due to global warming, and I wonder what you think about that with respect to Chagas, and what other diseases we might be seeing appearing in Texas as time goes on.
Yeah, well, warming. When Melissa Nolan looked at this, she's found evidence of Chagas, of triatamine kissing bugs and Chagas disease going back 100 years. So this is part of the problem, because we don't do active surveillance for these diseases. Mm-hmm. The question I'm often asked, is this new and emerging, or has it always been here and nobody bothered to look? And I don't know the answer oftentimes, but this is one of the interesting things about creating this National School of Tropical Medicine here at Baylor in the Texas Medical Center. Whenever we've looked, we have found it. But we often have, for instance, hookworm in Lowndes County, Alabama, or Chagas disease, or Christy Murray has found, typhus and dengue, including, Aedes aegypti and Aedes albopictus transmitted dengue and Zika. Mm-hmm. And one of the things I say about our school was we were created in the model of the London School of Hygiene and Tropical Medicine, or the Liverpool School of Tropical Medicine, which has been around more than 100 years. They recently celebrated their 100th anniversary. The difference, I say, is that we're in a disease endemic country, which is called the Republic of Texas. We have a fair amount of transmission, and I think it's a combination of poverty. We have 5 million Texans who live below the poverty line, so poverty is a big driver. When you talk to the climate change people, they say Texas and the Gulf Coast is being disproportionately affected relative to the rest of the country in terms of warming temperatures, as we've seen this past summer, or catastrophic weather events or altered rainfall patterns. Also human migrations, because the population is in such flux, as well as aggressive urbanization. So all of those forces are combining, I think, to make Texas and the Gulf Coast the disease endemic area, was the rationale for starting our school here. We also worked with the Texas legislature to create a Neglected Disease Act in order to start actively looking at this. So with the Texas Health Department and other universities, some of the public universities, we're now collaborating to do that kind of active surveillance, because a lot of times the diseases will get missed. It's not they don't get routinely picked up. When you go for your blood work and you see your doctor, you've got a little box for your blood chemistries and your blood glucose and your complete blood count, your CBC. There's not a little box there for the Chagas disease test, right? So they tend to be done in specialty labs, such as at our school or the Centers for Disease Control. So the vast majority of cases never get diagnosed, and physicians don't have an awareness of it. So we've now have a diploma in tropical medicine where medical students, physicians, PAs, and other healthcare professionals can get their diploma in tropical medicine or certificate course with us, because we want to build that whole cadre of healthcare providers who know something about these diseases.
Yeah. Wow. And with it, seemingly, it seems to be increasing. Well, we're not quite sure, but it seems to be been making an appearance in Texas.
Well,
we need to have that kind of education.
And people on some of the clinician scientists on our faculty, like Jill Weatherhead, Rogelio Mejia, Ava Clark, they have a tropical medicine clinic now, just for these kinds of patients, because they get referred, and you have specialty medicines and diagnostics. And
right.
that can pick some of this up.
Is there anything that we can do, to prevent ourselves from getting this disease? I was reading something that these animals, these kissing insects, tend to accumulate in like wood piles and leaves.
And poor quality housing. We don't really understand in Texas, how details of the transmission. Clearly the dogs are getting it. In fact, even some of what they call bird dogs in some of the wealthy ranches down in South Texas are becoming infected. How they're getting it, are they ingesting the bugs, or because of oral transmission? Some dogs will just eat anything, or is it just by sleeping? There's a kind of a small mammal called a wood rat that transmits it by being near there. So we don't have, is it the same transmission in South Texas as it is in the poorest areas of Bolivia or in Chiapas State in Mexico? I don't think we really know that.
Can we get it from the dog?
What? Not directly. So you can't get it directly from dog to human, but it has to go through that kissing bug and intermediate host.
Okay. So, and I also have a question that, because you said part of the population who is positive can go to either determinant or indeterminate, right? So do you think it's more important of the genetic variability among the population matters, or is this more about the different species?
So the question is it the genetics of the parasite, or is it the host genetics?
No, the human who get it.
Or the human host genetics.
Yes.
And the answer is it may be both.
Both, okay.
But it's understudied. I think there are at least 6 different genetic types of Trypanosoma cruzi, so that's one factor. But I think host genetics is really important. I think of the work of a colleague of mine, Jean-Laurent Casanova at Rockefeller University, who's done outstanding work, looking at the host immunogenetics and genetics of variability. This would be a great one for him as well.
Yeah. It seems like we should be, at least in Texas, we should be in patients that we see with heart failure of indeterminate etiology. We should be looking for Chagas.
That's absolutely right.
So would we send them to get their test at your facility then?
You could do that, or send the labs to the CDC. And there's several different antibody tests. They're mostly antibody-based tests. The problem that we get into sometimes is when there's not concurrence. So sometimes you get a positive result on one test and a negative result on the other, and so oftentimes a third test has to be done. There's also doing PCR of the blood For Trypanosoma cruzi is another. And in the old days, what they used to do, what was called, I haven't seen it done here in the U.S., it's called xenodiagnosis, because the bug amplifies it. They would have a collection of sterilized kissing bugs that they would feed on the patient's blood and then inspect the bug feces to see.
I'll get the blood test, thank you.
But, I don't know how you do that one at Quest Diagnostics.
So, leaving aside Chagas just for a moment, do you care to speculate as to what other infectious diseases we should be thinking about, maybe related to cardiovascular or not? Here in Texas, what kind of infectious diseases are emerging that we should be thinking about?
Well, I think the arboviruses are going to be very important. I mean, Zika is gone now, but exactly why it disappeared, I can't tell you. People say herd immunity. I'm not so convinced. Maybe that's true. So don't be surprised if Zika returns. Chikungunya, dengue, all of those are fair game. And there are other arboviruses that you find across Latin America that wouldn't surprise me. So I think there's a vulnerability there. Flea-borne typhus, I think, is one that we still see here. Parasitic worm infections. I mentioned hookworm, but one called Toxocara. So if you walk into poor neighborhoods, or even around Houston, you'll see stray dogs and cats, and almost all of them are infected with an intestinal roundworm called Toxocara. They're defecating on playgrounds and all over, and kids are coming into contact with the eggs. And so the seropositivity is significant, and it's a disease of poverty. The larvae that hatch migrate through the lungs to cause asthma. They migrate through the brain to cause developmental delays. But again, most pediatricians don't think of Toxocara if they have a child who's wheezing, or with eosinophilia, or if they have a child with developmental delays. So that's another one that's terribly underdiagnosed.
Are you thinking of developing therapies, vaccines against any of these viruses or parasites that you just mentioned? We tried to develop improved and point-of-care diagnostics for some of them, like Toxocara, as well as for Chagas disease, to make it a little more straightforward. When everyone did their home antigen tests with COVID-19, I think now there's this pretty widespread acceptance. Yeah, this is not too hard to do. It'd be nice to have that for other diseases, right? And so I think that's one. We haven't gone into vaccines for the arbovirus space a lot. But we've started some projects on West Nile virus for vaccines and chikungunya. West Nile, we don't talk about it enough, but Christy Murray and her team and Shannon Ronka have shown that West Nile is a pretty bad actor. I think the disease burden is underdiagnosed because some patients are going on to develop chronic renal disease and renal failure because of it, which hasn't really been well described before, but also chronic neurologic signs and symptoms, including depression. I think just like long COVID, I think those long-haul sequelae of a virus infection is not limited to COVID. We're seeing in things like West Nile as well. Whether or not it's the same pathogenesis, I don't think we know. West Nile is a mosquito.
Mosquito-borne, but it's not the Aedes aegypti or Aedes albopictus that transmits dengue or Zika or chikungunya, but rather the Culex mosquitoes that you see. So, during the summer here in Houston, the trucks roll up and they launch that big fog of insecticidal spray. That's getting mostly the Culex mosquitoes for West Nile, but not so much the Aedes mosquitoes, which, especially Aedes aegypti, which lives in discarded tires that are collecting water. So if you ever see tire dumping in a poor neighborhood, that's a signal for Aedes aegypti. And so during the Zika outbreak, I spoke with the Houston Health Department and the mayor about getting rid of the tires. And we didn't have Zika in Houston. Whether or not it was in spite of that or because of it, we have no idea. Of course, I'll take credit for it, but I have no idea what the impact was.
That's a good point. I mean, there's a lot of social engineering that could be done to prevent infectious diseases.
Yeah, I mean, if you go into some of the poor neighborhoods here in Houston, you don't have to drive very far from the medical center. You'll see discarded tires, you'll see dilapidated housing, sometimes without even window screens or air conditioning, which are conduits for for vectors of these illnesses. You'll see, standing water, which might be good for breeding Culex mosquitoes. So, you can go and drive through any poor neighborhood in Houston or in Texas, and it's like a poster child for tropical infections.
Wow. Well, we are nearing the end of our session with Dr. Hotez. Dr. Lai, do you have a final question for Dr. Hotez?
Actually, I just want to thank you for actually educate the public for the vaccines and also in general science. Actually, I watched the video that you filmed with 2 kids and introduced your research.
Right.
Yes, I think I may play that film to my son. And yes, you should get a shot. And our work is very meaningful.
Thank
right?
you. Thank you. Well, thank you for all your work and your
Yeah.
important research, and of course you, Dr. Cook, for all you're doing here at Methodist, and both in clinical cardiovascular sciences and your important research, and look
Thanks,
forward to continuing our association.
Excellent. Thank you so much, Peter. Peter Hotez, our local legend here in the Texas Medical Center. Dr. Peter Hotez has been talking today about Chagas cardiomyopathy, and you've been at the cutting edge of cardiovascular sciences. Thank you for attending.